Everyone wants to believe there's one final idea, one clean concept that, once you get it, the universe stops feeling mysterious and starts feeling like a solved puzzle. And if you read drawn to Feynman, it is partly because he seems like the kind of person who could hand you that key. He's clear, he's blunt, he hates fog, he doesn't do mystical language. He'll take something terrifyingly abstract and turn it into a picture you can hold in your head. So when you hear the line Feynman's famous warning, I think I can safely say that nobody understands quantum mechanics. It hits like a betrayal, because what do you mean nobody understands it? You invented half the tools we use to calculate it. You wrote the lectures. You explained QED. You could derive the numbers that match experiment at 10 decimal places. And you're telling me you don't understand it? But that sentence isn't a confession of ignorance in the ordinary sense. It's a diagnosis of what human beings mean by the word understand. Because most people don't mean, I can calculate the result. They mean, I can imagine what is really happening in the same way. I can imagine a ball flying through the air. They mean a mental movie with definite objects doing definite things in definite places. And quantum mechanics refuses to be that kind of story without you paying a price somewhere by smuggling in extra assumptions, or choosing an interpretation, or quietly pretending you didn't notice the parts that don't fit. A concept Feynman is pointing at the one nobody truly understands in the comforting, intuitive, classical sense is not just quantum mechanics as a vague label. It is the specific core feature that makes quantum mechanics different from everything your brain evolved to handle. The idea that the fundamental description of reality is not a catalog of facts, but a set of complex probability amplitudes that can interfere, and that what happens is not one thing, but the result of adding possibilities together with phases until they cancel or reinforce. That sounds like math, and it is, but it's also an assault on your deepest habits of thought. Because in everyday life, possibilities don't interfere. You either took the left road or the right road, and if you don't know which, that's your ignorance, not a feature of the world. In classical physics, probability is just a mask you put over your lack of information. Like saying, there is a 50% chance of rain, because you don't know the exact air motion. But the sky itself either will rain or it won't. Quantum mechanics is different, because even when you know everything the theory allows you to know, it still speaks in amplitudes and probabilities. And worse, those amplitudes can add like waves, producing interference patterns that are not explainable as ignorance about which definite path really happened. The cleanest place this bites is the double slit experiment, the one Feynman called the central mystery. You fire electrons one at a time at 2 slits, and you get an interference pattern, as if each electron is behaving like a wave that passes through both openings and interferes with itself. Then you try to find out which slit it went through by putting a detector there, by asking nature for the classical fact, and the interference disappears, replaced by ordinary particle-like outcomes. And the instinctive move is to say, okay, so it really went through one slit, and measuring just disturbed it. But if you chase that idea carefully, you find it doesn't actually rescue the classical story, because the interference pattern is not a fragile decoration. It's the whole phenomenon, and the rule that predicts it is not. It went through one slit, but we don't know which. It S, the amplitude for the electron to arrive at a point on the screen, is the sum of the amplitudes for each alternative, and the squared magnitude of that sum gives the probability. And when you add complex numbers, you get cancellation and reinforcement. And that's not how ignorance works. Ignorance doesn't make fringes. Ignorance doesn't make regions where the probability is near zero, even though either path alone would allow arrival. You want particles to have trajectories, because you grew up in a world where trajectories make sense. Quantum mechanics says trajectories are sometimes the wrong question. V's coexist in the formalism and only become a single recorded outcome when there is an irreversible interaction with a measuring apparatus and environment, what we call measurement, entanglement, decoherence, collapse, depending on how you like to tell the story. And here is where the nobody understands it. Pain really lives. We can write the rules down perfectly. We can use them to build lasers and semiconductors and atomic clocks and MRI machines and quantum computers. But if you ask for the simple picture, tell me what the electron really is doing, tell me what is actually happening, before I look, you discover there is no universally agreed answer that preserves all your classical intuitions, because every attempted picture breaks somewhere. If you insist the wave function is just knowledge, then you have to explain why the knowledge behaves like a physical wave that interferes, and why entanglement produces correlations that violate classical locality constraints in Bell test experiments. If you insist the wave function is a real physical thing, you have to explain why measurement seems to produce one outcome rather than a visible superposition of outcomes. And then you're in the swamp of interpretations. Collapse, many worlds, hidden variables, relational views, objective collapse models, all different stories laid on top of the same predictive machinery. If you insist particles are little objects with definite properties at all times, you run into experiments where those properties can't be consistently assigned without contextuality. If you insist the universe is fully deterministic underneath, you must pay with non-locality or with a structure that rewrites what you mean by deterministic. And if you say, fine, then quantum mechanics is just a calculation tool, you have to swallow the philosophical discomfort that the most accurate theory we have refuses to tell you what reality is, only what you will observe. Feynman's point isn't that quantum mechanics is vague. It is that it is brutally precise in a language that doesn't to map cleanly onto human common sense. And the human craving for a mechanical picture keeps trying to translate it back into a world of tiny billiard balls. And every translation introduces hidden contradictions. This is why he hammered on the amplitude viewpoint. Stop trying to imagine the world as definite classical facts underneath, and accept that the fundamental thing you compute is an amplitude, that alternatives contribute, that phases matter, that probabilities come from squaring a sum, not summing squares, and that the classical world emerges when interference between alternatives becomes negligible, when the phases wash out, when decoherence destroys the ability of branches to interfere, when huge numbers of degrees of freedom make quantum coherence effectively inaccessible. That emergence story is real and powerful, and it explains why tables look solid and why cats don't appear in visible superpositions. But it still leaves you with the uncomfortable truth that at the foundation, the universe is not a set of events in the way your language implies. It's a complex valued structure evolving in time, and your classical narrative is a coarse-grained summary. That works because you live in a regime where quantum phases are usually scrambled beyond recovery. Makes people feel broken when they really absorb what Feynman meant. You can fix this by thinking harder, because the limitation isn't just a lack of cleverness. It is that the concept of understanding you trying to satisfy understanding as a single visualizable mechanism. One definite story may not be compatible with the way nature is. Quantum mechanics might be one of those places where the most honest relationship you can have with reality is not, I can picture it like a machine, but I can follow the rules. I can see how the rules connect. I can compute, and I can build intuition that is faithful to the mathematics, even if it never becomes a classical movie. That's not failure. It's maturity. It is the same move you make when you accept that the Earth is spinning, even though it feels stationary. Accept deeper, because here the mismatch is not just sensory, but conceptual. Term effects uniquely, because that's how everyday objects behave. Quantum mechanics says sometimes the best nature offers is a distribution, and the distribution is not ignorance, but structure. You want the world to be made of things with properties. Quantum mechanics says properties are not always possessed independent of measurement context in the way you imagine. So the one concept Feynman said nobody truly understands is the quantum mechanical way the world adds possibilities, amplitudes, superposition, interference, and the way that undermines the classical demand for a single definite history underneath. And if you want the most Feynman-like takeaway, it's not despair, and it's not mysticism. It is a kind of tough love, done to fool yourself into thinking you understand quantum mechanics because you can recite words like wave-particle duality, and done to fool yourself into thinking you can't understand it because you can visualize it like a ball. Understanding in this domain means you can use the principles consistently, you can predict correctly, you can see how experiments force the rules, and you can resist the temptation to add comforting stories that aren't required. Quantum mechanics is not asking for your approval. It's not trying to be intuitive. It's simply telling you, with merciless accuracy, what happens when you ask nature questions at small scales. The answers come as probabilities built from interfering amplitudes, and the classical world you live in is the stable shadow cast by that deeper structure. If that leaves you unsettled, good, because that unsettled feeling is the honest, responsive mind realizing that reality is not obligated to fit the shapes your imagination prefers.